Hello, my name is Kim Sauer at What's New in Electronics Live in the What's New in Electronics TV studio. I'm here today with a great panel who will be discussing automation and robotics. So we've got Michael Ford from Mentor, David Pickavance from KwikTic, and Karl Miles from Peak. So actually, Karl, I'm going to start off directly with you because here at the show at What's New in Electronics, you do on your stand have a robot arm. Right. Can you just introduce that as an introduction to the theme?
Okay, so we have a Rethink Robotics, a robotic arm that we've attached to the automated test system, and this is there then to actually load the product onto the test fixture, and the test fixture then goes in and tests the product, and then it unloads the product at the end. And the idea of this is that this can then be left unattended, obviously, and then works its way through testing the boards. And obviously this saves you having an operator then to actually do that process.
And that's actually a good introduction. So robots are here. Robots are doing some aspects of manufacturing. What I'd like to explore is, how present are they already in the manufacturing process, and why are they being implemented in that? And then we'll explore a little bit about some of the issues that we're facing with those. So from your experience, where are we seeing robots?
A lot of the operations with the so-called back end of electronics manufacturing are still being done manually. Now, it is hard to find people who enjoy to do that kind of job. And I think originally in the 1980s, we saw an influx of robots coming along that would do very simple jobs. I mean, what you described, but in a different way. It was really just pre-programmed where to pick up and where to place. And the technology was a little bit dodgy. You had to do a lot of maintenance or a lot of problems. And so we saw a growth in automation, and then it almost went away. So, today in the factory, you could walk around, and it doesn't look that different from what it looked like 20 years ago. So fast forward to today, and the kind of robots as we see from you, now we have a whole new generation. Not only has the software got better, but the things like the sensors on the robots are better so that they can know exactly where they are, they can feel and touch things. That has brought the revolution in robotics. And so from now, I think we will see a huge growth. Because until now, it's been and gone, almost. Okay, there were certain applications that were fine, but generally we still see a lot of people in electronics manufacturing.
So robots are not taking over people's jobs, but they're assisting people.
Yeah, that's the key thing we see is that sometimes it's not even taking their jobs. There's customers we're speaking to at the moment, and the problem they have is they can't actually get the staff that they need. So there's not the people there to even hire. And then when they do get some staff, as you say, it's not exactly the most interesting job, so they have a high turnover rate. So then the guys come in, they have to retrain them, and therefore, to them, they're looking at not replacing them as such, but giving them a different task that's maybe more interesting, and then let the robot do the laborious, boring, repetitive work that it needs to be done.
Yeah, it's like, hundreds of years ago, you had people going down the coal mines with little picks and things getting bits of coal. Then somebody came along and said, well, hey, you can use a drill. They're not going to say no, but you see a reduction of the number of people, but the number of people who are then left to do the work experience a higher level of skill and productivity. And it's the same with the robots. So in electronics manufacturing, you used to have people stuffing parts on boards or putting fixtures, boards on fixtures. Now, if the robot can do that, does that replace the operator? Of course, yes, it does. However, you need to have somebody to program the robot. You need somebody to maintain the robot. You need somebody to figure out the best way of using the robot. You need somebody then to connect the robot with the rest of manufacturing, preparing the programs, feeding them at the right time, making sure the versions are correct, getting the data from the the list just goes on. But what we're doing is replacing a nasty job that really was not interesting for anybody, and we're replacing it with jobs that are more interesting. People love to play with robots. You put the robot on your stand and people are coming along to see it because that's what they want to do.
I think it's also the productivity. There's a lot of talk on the news and the politics about the low productivity in the UK, and that's where with the robots, that's how you increase your productivity. You have one guy maybe looking after 4 robots. Well, straight away now your productivity per man has gone up. Can't not do.
And it's also taking out the errors as well. There's a lot of tasks that are out there on the shop floor which might seem simple, but when you've got slight variations in products, putting a robot in place providing it's programmed correctly and you're passing the correct program into the robot, there's less chance of errors on there.
That is actually a good point, because you often see that if you're making a large number of variants of products, as we are today in electronics manufacturing, each one of them has a slightly different set of instructions. To a robot, that's a walk in the park, because it does what it's told. To a human, they've got to think, because you set up an operation standard for a human, and they will go through it. The second one, they'll hardly look at it. And then the third one, they know it off by heart. And then they change variant, but they forget that they've changed. And so quality is also improved radically with robots, I would expect.
It's actually, as you improve your processes and you have a high yield rate, the worst thing is the operator actually becomes fail blind, because he's seen 60 boards pass. So the next board that comes along that fails, well, he just puts that in the pass pile because he hasn't seen it anymore, because he doesn't expect it. So if you improve your processes, improve your yield, you actually need something which will pick up that one failure in 100, because the operator just misses it. Because I've seen operators do it, it's come up fail, and they've just put it in the pass pile.
Yeah, the expectations just seem to change when they see the trends.
Yeah. Well, it's like driving. I mean, you're driving a car and you're supposed to be aware of all times. Then you get somewhere and you think, oh, how did I get here? You're not conscious of it. It's like an autopilot took over. And that happens in manufacturing, and that's the thing that causes those kind of problems. It's a natural human thing, isn't it?
Remind me never to drive with you anywhere, Michael. But robots on their own obviously have a function, but then there's a communication that they need, a role they need to play to communicate what they're actually doing and how they're doing it, and that human operator that becomes blind of what they're actually doing will still have some sort of communication back to the overall manufacturing site as to what they're doing. So how are we integrating the actual physical robot in its form with the manufacturing environment?
Well, I think that's the big change to the robots you saw before, because they were very much one task, had to be guarded because they could hurt people, whereas the robots you're seeing come through now are the collaborative style robots, and that's what we've got in our stand. There's no guarding around it. If you get in its way, it'll bump into you and stop. So it's exactly like working with another human being. And that's, I think, the change you see now. And as you said, the technology's moved on. The vision systems now that are there so it can actually look what it's doing. So it's not just working blindly, pick up here, drop here. It goes to that place, it tries to pick up. It can check the boards the right way round, for instance. And it can do all those things that before the robots weren't doing. They had to be fed a certain way, in a specific way. Whereas the ones we're seeing now, they're working with the operators in some cases, and they're doing tasks with the actual operator. So it's like working with a colleague.
But is there a standard way that you take in programs or store certain sequences that the robot would follow and provide interfaces so other systems can speak to that? And
Quite correct, yeah. So the robot's ready to program, you just take it to where you want it to go to, and then program it at that place, then say go to here. And then you can interface from there into other systems, and that's what we do, because we're taking the robot and actually interfacing it to a test system. And then obviously the back-end data for that into your manufacturing database then goes back from there then.
Could I mention the S word, standards? I think there are a lot of, your robots are excellent, and there are other robots on the market as well coming along that are doing similar things. Is there a common language to this? I mean, this is a question that went back to the start of SMT days, where different vendors were producing different machines. Are we now down a path where we have different engineering information? I mean, the answer is yes, because the robots are different levels of ability. But is there some kind of way of having, for example, to transfer the program from one robot to another robot without having to start again and teach it? These are the kind of questions that come up for flexibility, you know?
Yeah, you've got, we integrate more than one robot, so we also look to the ABB robot as well as the Rethink robot, so we can integrate that with our system, and then really it's the integration of the robot to the test system and to the rest of the manufacturing line. You can't take a program from an ABB robot and put it on the Rethink robot yet, because they're different systems, but that is kind of almost isolated from that, because you've got that barrier of interface to the actual system then.
Because I think that the real problem that almost killed the robot industry in the 80s was the fact that there was no flexibility at all. A robot was specifically designed to do one job with a specific product. A variant comes along, okay, new one, and that's no good. Today's robots like yours, they're able to be programmed to adapt very, very easily and simply. And this is the critical factor for success I see in the industry, because the industry has been made to be more flexible with more variants of end products. And so how we replace the human operators, which are themselves very flexible robots, albeit with a forgetful memory, we need for the robots to be that flexible.
But I think even when you look at the standard processes that are out there on the shop floor, so the likes of the AOI machines, the pick and place machines, even between each of the different vendors and different types of platforms, there's no real standard there for input of data.
Absolutely, and I think there's a lot of work going on in terms of standardization and standard language, particularly driven by the Industry 4.0 initiatives out there. So this is definitely something we need. Now, I just want to touch upon where these robots are becoming maybe more relevant than anywhere else. So there must be industry-specific applications where a robot is being put, and others maybe that are less relevant. And we're also in the UK at the moment, so I'm just wondering, A, which industries are we putting them into, and which UK industries are being supported by, you know, putting robots into manufacturing?
Yes, so the applications we've seen are, I mean, there's not just loading obviously the product into the test fixture. The same robot can be used to pack products as well into cardboard boxes. There's an application for it building light fixtures as well. So sheet metal working, where it's actually loading the sheet metal into a press. So there's quite a few operations that, you know, you just adapt it. It's got a very, you know, multi-joint arm, 6 axes of movement. So really it's, you know, taking the robot and just putting it in front of where the operator is. And I think that's what you see in the robots now. They're not trying to replicate a human, but they have the movement and capability to do quite a lot of tasks, which are, you know, pick up, place here, press the metal, you know, or test the board, and then move and then go somewhere else. And I think that's the difference you've seen. Rather than having a big gantry fixed robot that can go from A to B, it's that dexterity and movement you see in the arm and the rotation that really mimics a human arm effectively then.
I guess the key technologies are the sensors to be able to feel when something's right or wrong. And then also the vision to be able to see that, for example, the lead is not where the hole is, and be able to then position it. So the software algorithms that go into that real-time operation of the robot are what defines where it can be applied.
Yeah, and it's even the cost has come down dramatically as well. You know, I think that's where you saw maybe the robots kind of came in back in the 80s at a very high cost, and they stayed at that high cost, and that for the flexibility you're talking about, you just couldn't justify the investment. Whereas now the price is heading southward, and, you know, it's a more competitive market now. There's more than one vendor offering the same type of robot, and I think you see it for every industry. As that starts to happen, then that's always going to have a downward pressure on the price then.
Is that because robots are becoming more intelligent in terms of the controls and the way that they can correct certain features or functions that they're doing?
I think so. It's also obviously just general electronics pressure downward on price, really. So the motors and the sensors have become much cheaper now. The cameras that you need are much cheaper. You know, and I think it's like any industry, as you get that maturity on those type of things, that the price, and I think the sensors also have been used in other applications as well. You know, you talk about a gyro that before was very expensive, and now they're in every single mobile phone, and as you get that mass production for various, and then you reappropriate that technology into the robot, obviously it's not just designed just for the robot now, it's come from other technologies and other industries then.
So we're not necessarily saying robots are here in specific high volume manufacturing environments. They can also be used quite intelligently in high precision in medical.
There's almost actually a sweet spot for the robot, because if you have very low volume, then you're going to still do it by hand. If you have very high volume, you're probably going to go to an inline system. So you're not even going to use the robot, then it's too slow. So there's a nice sweet spot in the middle, which is you saying it's the number of variants you have, and you want to keep changing what that robot's doing. That's where it fits in, because that's where you need that dexterity and the ability to quickly reprogram it, do this task today, and then tomorrow, you know, or this afternoon we're doing another variant, and it's a bigger board, a smaller board, and that's where you really see the strength then.
Okay, well, thank you very much for your views today. Thank you for participating, and good luck with the show here. Thank you.
Thank you.
Thank you.